great to be here. It's really a pleasure to see everybody here and to be at this event. So today we're going to talk about going from medicine to Medo.ai, how we started an AI company from academia. Medo.ai is an Edmonton-based medical imaging AI startup company, and it started with academic origins. So basically, this is an origin story. Now, we're going to start with a little bit about me and my origins and where I am now. I have quite a few current roles, as Stephanie pointed out. So I'm on the academic side. I'm an associate professor of radiology, becoming a professor July 1st. I have a Canada CFAR AI chair. There are about 100 of these, and as far as I know at this moment, I'm the only practicing physician with one. I'm also a partner at Medical Imaging Consultants, which is Canada's largest radiology partnership, as far as I know. And in addition to co-founding Medo, I'm a fellow at Amii, which is putting on this event. So I'm from Alberta. My grandparents are from the Ukraine, Hungary, UK, and Norway, which makes me Canadian. I'm born in Calgary and have lots of roots up in northern Alberta, northeastern Alberta, Elk Point area. I started my academic training with civil engineering, so I'm quite far from where I thought I would be originally. I've started out doing structural design and highway design, and the thing to notice on this slide is this dates me or shows my age a little, is that those pictures are hand-drawn on graph paper. So that's what we were doing in undergrad. Email arrived when I was in third year. So then I went on and did a combined MD PhD, and when I was doing the PhD, I was in biomedical engineering, and what I was working on was relating surface and spine deformity in scoliosis. So this was a project using genetic algorithm neural networks. And so these neural networks, these initial fully connected neural networks, is sort of an earlier generation of the deep learning that we're working with today. Then I did my clinical training. I did medical school in Calgary, radiology specialty residency training in Edmonton. And I did 2 clinical fellowships, which were in great cities, Melbourne for my pediatric radiology and Boston for my musculoskeletal radiology at MGH. And so saw how a lot of things are done differently in different parts of the world. And in fact, the original idea that led to Medo, really that hatched Medo, came while I was down under on my fellowship in Melbourne. I was learning how to perform ultrasound of babies to see whether their hips were normal or abnormal. And sonographer Kane Broccoli, this is a guy who's about 7 feet tall, which is amazing when you're dealing with kids this tall, this huge guy. He says, why can't we look at the whole 3D shape of the hip when we're scanning? Why are we just looking for one picture? So, that really twigged with me, and that stuck with me, and I thought about that a lot. So to understand what that means, we have to talk a little bit about a specific medical condition. So developmental dysplasia of the hip is a common abnormality. It's about 1 in 100 or 2 in 100 people. The baby is born with an abnormal shape of the hip and can develop premature arthritis from it. So the hip on the right side of the screen is a normal hip. So you can see that the top of the ball and socket joint, the socket is well formed, and when the baby learns to stand, then the loads are transmitted between bone. But on the left side, it's dysplastic, and that acetabular roof is very shallow and steep. And so when the load is transferred when they're walking, it actually is unstable and leads very quickly to wear and tear on the joint. And so hip dysplasia, what we'd like to do is figure out whether it's there when the baby is still a baby and the cartilage is all soft before it turns into hard bone. Because when it's soft cartilage, you can fix hip dysplasia. You put a patient into a harness and you can cause the ball and socket to remodel while it's still soft cartilage. If you miss it while it's soft, you've missed your chance, and you have to go on to numerous surgeries afterwards, and basically the patient ends up with a lifetime of hip arthritis. So it's one of those things that we should be detecting early. The problem is that the way to look at it is with ultrasound, pictures that are quite complicated to understand. So the picture on the left of the screen is this really blurry image where I've highlighted a bunch of anatomy so you can see which parts there are. The femoral head, the iliac wing, labrum, os ilium, os ischium. Ideally, of course, we'd have a beautiful 3D model of the hip with anatomic renderings. But what we have is these blurry images, or not blurry, but different images that are complicated to examine. So now what we did, when I started in Edmonton with my academic position, we started looking into the problems with conventional ultrasound screening. And we found out that actually, if the key to the whole issue is determining the alpha angle, you can see my laser pointer if you're live in the room here. Let's just see. Oh, not really. Never mind. The key to the diagnosis at the lower right of the image is the alpha angle. And so that angle, when it's over 60 degrees, is considered to be normal. And if it's in the 40s, then that's abnormal and needs treatment. But the little image at the upper right of the screen is basically just moving at different angles through a 3D ultrasound data set, showing that if you just move your probe, you can produce pictures of almost whatever angle you want. So that suggests that there's a bit of a problem with the diagnosis of ultrasound of hip dysplasia from one picture on ultrasound. Because if you just take one picture, you're going to get it unless you really trust your user, then you could have a diagnosis of an abnormal hip. And in fact, that's the problem. This translates into screening being resulting in a lot of false positives and very expensive because you keep bringing patients back to check, and you end up with no benefit to patient care in the current scheme. So technology can come to the rescue a little. We started with 3D ultrasound. This is actually a pretty fancy, it's a 13 megahertz probe, and it's pretty simple design, but what it is a normal ultrasound probe, but it's in a really thick housing, so it actually just mechanically sweeps from one side to another to generate a stack of images. And the stack looks something like this. And here we have Dornusha scanning a baby back in the old days when she was my postdoctoral fellow. And so these scans, it takes about 3 seconds. When you're holding the probe, you feel the thing vibrate as it goes through the scan, and it generates this stack of images. And then you can see visually, you can tell whether the hip is normal or not. So if you look on the images on the left, you can see that a normal hip has that sharp angle, really steep shelf appearance, whereas the dysplastic hip on the right is kind of a more rounded appearance. And so that appearance is, we think, more visually obvious when you have the whole stack of images than when you just have one. So that's all great, but we've generated this huge data set for every single baby. And if you want to get somebody to manually segment the data so that you can manually identify where the landmarks are in it, this takes quite a bit of work. There's 250 slices per hip. And, it's kind of a labor of love, and we've had graduate students spend many, many, many hours manually drawing these labels. And we even had one of our graduate students quit. So what we thought we could do is we'd like to automate this analysis. All of this analysis needs to be automated. So this is the vision. You could screen every baby if you could just, scan the baby, put it up into the cloud, and then the computer thinks about it, looks at the pictures, and then gives you an answer. Okay, this baby's fine or not. That would be whole population screening. It would be cost effective. So right around this time, this was 2017, and right around the time that artificial intelligence strategies are really exploding. Deep learning, convolutional networks, UNets, really becoming very, very popular. And so we thought, well, we can automate this. And this is where Dornusha started to come in. So strategies for this, you could have a convolutional network which basically produces the shape mask, so it automatically does the segmentation that our graduate students were doing, and then you have the shape, and then you could have a human observer look at the pictures and see if they think it's dysplastic or not. Or you can have an end-to-end approach where, in fact, you have this original layer, and then at the end you have some final fully connected layers, like the ones that I started with way back as a grad student, that predict the diagnosis. You basically get that checkbox, it's normal, or X, it's dysplastic. So image segmentation is key to this exercise. And this seemed really difficult back when we first started. We developed deep learning networks to replace the user identification of the seed points. And there was a series of attempts over quite a long period of different neural networks, which were using information either 2D, so just from individual slices, or 3D, where we tried to use adjacent slices. And as you can see, it started out a little bit poorly. That first one on the left, the computer found the acetabular roof, the bright line, but it also found a whole bunch of other stuff next to it, which wasn't quite right. And then we thought, okay, it's too sensitive. Let's back off on the sensitivity a bit. We revised the network design, and then it started to capture parts of the acetabular roof, but it wasn't picking up all of the bone, so it was not sensitive enough. And then we did multiple refinements, which eventually led us to get the acetabulum, and we can even get the femoral head, the dark thing now. There was a period in there when, getting that dark structure was really difficult. The bright line we finally were able to capture, but then the dark thing, the femoral head, was like this sort of black hole we kept sinking into. But we eventually found it. And then we published this paper. This is, you'll see that Dornoosh is first author on this one, which was a multi-center study between Canada and Australia, looking at almost 2,000 hips, where we'd used the automated analysis, and we demonstrated that it really worked. Just what it actually did more specifically, on that little pie chart on the left, you can see that blue is normal, orange is dysplastic, needing treatment, and the yellow was borderline. So those are cases where one picture that a sonographer took, where that one picture was questionable, and they had to bring the patient back and scan them again, and maybe scan them again and again. And that's the part that makes screening, frustrating for families or expensive for the healthcare system. So to avoid that, we used the 3D ultrasound, and you can see we correctly picked up all the normals and dysplastics, but then we shaved that borderline down to a very small amount. So there was hardly any cases that were indeterminate, and that's the beauty of having all the data. So this was exciting stuff, but how do you actually go from an academic, we've had this great idea, we've published this big paper, but it doesn't really have an impact unless we can actually start screening babies and start building these tools. So little did we know at the time we were embarking on a path towards commercialization. It started with something called CUDDLE, the collaborative and ultrasound deep learning, and we thought that was a very warm and fuzzy name for something. It was an academic collaboration, couldn't really go beyond research, and we thought, well, CUDDLE's great, but we need to think a little differently here. And Dornoosh at this time was dreaming, and she was just dreaming, and she was thinking of something else she could do. And I was offering her at the time to extend her fellowship with me and stay on working with us. But instead, she was thinking otherwise, and I was a bit worried she was going to head for the Army. Here you see she was actually wearing combat fatigues, but luckily she didn't join the Army. Instead, she decided, let's build Medo. And so we, in 2018, early in 2018, we founded the company Medo. Dornoosh is the main founder and CEO. It also involved me as one of the founders, and then Jivesh Kapoor. He's a radiologist in Singapore who was instrumental in putting this together. And so I'll turn it over to Dornoosh to talk some more.
Thank you so much, Jacob. First of all, hello everyone. It is such a pleasure to be here today and to get the chance to share a bit of my and Medo journey. As Jacob said, this is also an origin story, so I thought I will start with my origin. I was born and brought up in a beautiful city in Iran called Shiraz. It's known for its poets, literature, and gardens, and some of you might be surprised to hear that city is the birthplace of the Shiraz wine. After that, I moved to Singapore to do my master's and PhD in the field of medical image analysis. And I feel that heritage and culture in Singapore really contributed to my personal and professional life. Well, after Singapore, I was very keen to move to Canada for my postdoctoral fellowship. I had no idea where Edmonton is, and I had no plan to move to Edmonton. Most of my family and friends live in other cities. But then there was this interview call in the midnight time Singapore with Jacob that changed all that. His calm, humorous, his passion for research, with that he convinced me that Edmonton is the place to move to. And well, I got super excited, packed my bag, and just didn't think twice about it, moved to Edmonton. And since moving to Edmonton, I'm falling in love with the city and all the things this region has to offer. And Edmonton really made me feel at home with all the amazing people and the sense of community. So it has been super, super, super fun since then. Alberta Innovates actually gave me a very generous fellowship that enabled me to travel extensively and made all these collaborations that eventually turned into Medo. This image is actually day one, literally day one, when I moved to Edmonton and joined Jacob's lab, and became a long way since then. Jacob told you a little bit about how Medo started. I want to talk a bit about our vision, because as he was talking about hip dysplasia, it started with hip dysplasia. But as we went further, we realized that our vision is actually a bit more and above and beyond just hip dysplasia screening. Our vision at Medo is to bring medical imaging, make medical imaging available to anyone when and where they need it. And we believe this is not only our vision. Having access to timely patient care is actually a basic human right. And patient care starts with a diagnosis, and medical imaging is such a vital part of reaching to a diagnosis. So what is the problem? The problem is that at best case scenarios, access to medical imaging is very centralized. Like even for us here, we need to get to hospitals, we need to travel, wait for appointments to get that medical imaging done. But unfortunately, this is the best case scenario. In worst case scenario, there is zero access to medical imaging. 2/3 of the world's population, no access to medical imaging. When we need it in emergency room, in ambulances, during times that things are tricky, no access to medical imaging. And we believe ultrasound can change that. And I want to talk a little bit about why ultrasound, because we are very, 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 very focused on ultrasound, and there's a good reason behind that. While CT and MRI, harmless, cost millions of dollars, barely fit in trucks, ultrasound is safe, truly portable, and it can very easily reach every patient where and when they are. You might actually literally have an ultrasound probe. A clinician can actually literally have an ultrasound probe in their pockets. Jacob, do you have an ultrasound probe? Such a coincidence.
Yeah, coincidentally, I've got one right here.
Yeah, ultrasound is this portable. It is safe, non-invasive. You can literally put it in your pocket and walk to any patient and look inside their body rather than using a stethoscope invented in the 18th century to hear what is going on inside their body. Like, we believe clinicians should be using this tool. And can send the images to your iPhone, to your iPad, and there you go. You have a window inside the human body. And it has been such a huge recent advances when it comes to the hardware of ultrasound. Now we have ultrasound on a chip. Cello is one of the examples, right? Literally ultrasound, all these capabilities of, there was a time that ultrasound was a huge machine. Now you have all the capabilities on a chip. What does it mean? Now we can have wearables. Now ultrasound can and will come to our homes. So super exciting when it comes to the hardware. But there is a catch. There's always a catch, right? What is the catch? The catch is that ultrasound is very, very, very difficult to work with. As he said, images are just like noises. So acquiring good images and understanding what they mean requires extensive training. And because ultrasound is a handheld modality, right? He was holding it in his hand. It's very operator dependent. So that, yes, the devices are becoming cheaper and smaller and more available, but we do not have enough expertise to go with the devices, and this is the problem. This is why our family doctor doesn't bring his ultrasound to look inside our body. This is where the problem lies, and this is where AI and Medo comes in. So we are working on technologies that would actually basically provide that expertise, right? How to acquire a good image, how to understand what is going on. In terms of vision, super straightforward. It's just the devil is always in the details, right? And we believe if you combine the ultrasound hardware with AI and with that expertise to how to use it, then you're eventually gonna have the stethoscope of the 21st century. Or for those of you that might be a fan of Star Trek, well, medical tricorder can actually come into reality. It will come into reality, right? It is exactly what we are working on at this point. So yeah, super exciting. I'm gonna leave it to Jacob to talk about how to actually navigate and what are the challenges in building a deep tech startup like Medo. Thank you so much.
Okay, great. Thanks, Dardouche. This is incredible stuff, this technology, and to take this probe and actually do something with it that is even more meaningful. I just love the passion that Darnush brings to this, and that's it's very exciting for us all. So now, so we have this vision, we have this dream, and the question then is, how do you actually execute on that? How do you actually transform this into reality? So, you know, at the bottom line, one of the things you need is lots and lots of money. Lots and lots of money. So this is always a challenge. If you want to go from a startup, if you want to start something from scratch and build it to commercial, where's the money coming from? So a source that people commonly use, which we actually did use, is incubators or accelerators. And that's something that we're quite blessed with in the Edmonton region. There's at the university or in the city, supported by different levels of government and different organizations that want to help people do this. And so they supply some of the expertise and the commercial expertise and contracts where they supply funding in exchange for some equity in the company. Another way to do it is to be self-funded. Of course, if you're fortunate enough to be, to have been born with a lot of money or have some friends, angel investors that are wealthy enough to just throw in a couple mil here and there, then you're fine. But we weren't blessed with such a thing, so we had to go the incubator accelerator route. And another thing that we took good advantage of is grants. So, and especially if you're coming from an academic environment, there is the option to pursue commercialization grants or grants that go all the way along the spectrum of commercialization. And for that, I have to particularly be thankful to Alberta Innovates, who has several different grants at different stages along that spectrum, which have been extremely helpful to us. So that's part of an advantage that you have in Alberta, is extremely supportive that way. So if you get the money, then what do you do with it? Well, for Medo, we actually started with an incubator in Singapore, and we went to rounds of funding from venture capitalists after that. Now, just an interesting point is that in the incubator process, generally what they're looking for with a startup company is they want the founders to all be full-time, like skin in the game, that's it. You quit your job, you're going to work and do this. That's all you're going to do. And so it was extremely controversial back in the incubator environment that Jivesh and I were not quitting our day jobs. We were going to keep working as physicians to do this. And that's not incidental. Like, I see myself as a physician. Like, that is my role. I'm a radiologist. And it's also essential for, in a medical startup, you need to have practicing clinicians involved intimately in the team. Otherwise, people don't know what to do with the technology they're developing. So that was very controversial, but it's a testament to Darnush's powers of persuasion that she was able to, successfully convince the incubator folks that they should make an exception to their usual rule and let 2 of the 3 co-founders of this one be part-time. In fact, very part-time. I'm full-time in my clinical and academic work. So this is, we're talking about evenings and weekends here. So once you go, you've accumulated some funding, you need to really think about which people you're going to work with. You need people that are reliable and trustworthy, people that are absolutely committed and are able to commit meaningfully to the project. And, honestly, this really starts with family. So Darnush's team, that's Darnush with her brother, Dinesh. He has awesome hair. And he is actually, he's a very hardworking computer science guy who has done a lot over the years with Medo. And then that's my 3 kids. And all 3 of these kids have been scanned extensively with ultrasounds over the years. So,
also has the largest nodule we can see in the thyroid.
Yeah. That's right. Dinesh has also been modeling for us for one of our other projects, which is on the thyroid, because he has a nodule in the thyroid. Yeah. So we start from a nucleus of family, those people that you can absolutely rely on, and then you build a team from there. And so this is like growing a tree. I'm not a very good gardener. Darnush would be an excellent gardener if she turned her attention to that. Because what you're trying to do is pick people balancing expertise. You have a small team and you need it to grow. And at every stage of that growth, it has to grow successfully to the next level. So links and trust are crucial. And you have to be careful pruning amongst. So some people are better suited for an academic environment and some people for an industrial environment, and they might not know that until they try working in one or the other. And it's important to point out that a startup company is not a union job. You're not punching in and leaving at certain hours. This can be all-consuming. So you need the people that are willing to commit a lot to it and that have the right temperament and passion for work on the team. So Darnush has really built, as the CEO of Medo, has really built a team that we love. Everybody there is just a great member of the team. So it is very difficult to recruit talented people. And I'd point out that Edmonton has a few liabilities here. It's cold in Edmonton. It's a lot colder than it is in San Francisco. And it's a lot colder than Singapore. So one does have to keep that in mind. We personally believe that Edmonton winters are beautiful. You cross-country skiing, access to the mountains, fresh, clean air. But not everybody who's an AI scientist sees that as where they want to work. So we have to work with that. Also, we're paying people in Canadian dollars, and sometimes people have, somewhat unrealistic expectations of what they can make. It's difficult to recruit, especially in the current environment. There's a global pull for talent. Someone who's got an AI science background or a computer app developer, even just any role right now is just hard to recruit for. So luckily what we have going against those liabilities is our assets, which is our vision. Like, this is not just another, it's not, the purpose of this, of Medo, is not just to go and make money, right? Like, obviously it'd be nice to make money to pay all the employees, but the vision is the 21st century stethoscope, right? This is an idea that drives us. And it's something that a lot of other startup companies don't have that kind of a, that kind of a vision, or something that you, at the end of the day, you can feel like I did something really useful. And that's been what's been driving me academically all along. And it's great that there's an opportunity to make it happen in a commercial setting as well. And also, we just have fun together. Darnush throws great parties. So that's, there's a lot of dancing. There's, it's just a fun environment. And that's what, sort of comes by it naturally. I think, a lot of companies try to sort of manufacture that, and academic departments often do even worse at trying to manufacture the fun. But Darnusha and her family and friends, just a great group of people to hang out with. So that really helps when you're recruiting people into a company or when you're trying to build a team. This is like not a small thing. This is a very important thing, to have people that really enjoy each other and are working together towards a shared vision that is a really important vision. So you also need local friends. And luckily, as I mentioned earlier, the Edmonton community is exceptionally supportive of AI startups. And so we've been just blessed by this. We've got Amii, we've got Alberta Innovates, Health Cities, MITAX, the Alberta government, MIC has been extremely supportive, and the University of Alberta. So, and that's just some of them. So, for example, office space. So this building here, Medo has a very, very favorable agreement for its office space in this downtown tower. And the view from which floor is it? The 15th floor. The view from the 15th floor over the river valley is spectacular. And so everyone's just lucky to have that. And so office space and a place for people to gather is very important. Networking and connections within the AI community. And that's what we're here for at AI Week today. This week is meeting everybody. And you can see that the community is a great size to be working together. Co-founding and assistance with recruitment. So many different ways that local friends can help. And I just feel very fortunate that Edmonton, I think there are a lot of people who have the vision that Edmonton needs to avoid being Detroit and get out of, just oil and gas. If oil and gas is kind of a fading industry, we should be diversifying into tech. And we have this downtown, which, has some vacancies. We have some extremely smart people at the university and at Amii. And why not take those resources and diversify into tech and into AI and actually into the medical academic complex? And that's something that's really good in Edmonton. At the university, just on the other side of the river there, the university is on the north side of 87th Avenue, and the hospital is on the south side of 87th Avenue. And so they're right next to each other. We have a medical academic complex, which is really growing. And just on that point, I'll just mention that when I'm a physician, when I'm a radiologist, I'm actually on call. This week I'm on call for any kid who's sick. I'm on pediatric call, and I'm on call to the North Pole. So Edmonton's the last major city before you get to the North Pole. And so, the people coming to us are coming from Yellowknife, Whitehorse, Northwest Territories, Grand Prairie. If Santa Claus got sick, he would come to the University of Alberta Hospital. So we are covering a vast region, and we bring a lot of medical pathology, people that are sick from different complicated things. And they're all coming to Edmonton. So it's a great place to build healthcare innovations because we have access to this huge pool of it's a huge catchment area of disease and people that we can help. So there's a lot in our favor in the Edmonton region, which I really like. So that's all great. Again, that's still a bit theoretical, right? So we have to move into actually executing. And one thing we need is contracts and agreements. So in AI in particular, the whole, to build an AI model, a deep learning model, needs a lot of data. You need thousands of patients. You need approval to look at all that data. So as we were discussing in seminars and such yesterday, that can be pretty controversial. So first of all, there's ethics approval. So the University Ethics Committee has to agree to let you, that it's not dangerous for patients for you to see the data. You have to have data transfer agreements. Now, just look at the red circles of that agreement. It's an agreement between Alberta Health Services, which is actually Alberta's largest employer, the University of Alberta, which is Alberta's largest university and one of the largest in Canada, and then me and Medo. So you can imagine an agreement between those two huge institutions and us is, the length of time it took to negotiate that is quite long. And we are actually revising that agreement as well. There's some things that need to change. So, negotiating that's a big job. We also need operational approval to actually work and test things in medical environments. That is not trivial. You need memorandums of understanding, non-disclosure agreements. If you want to talk to anybody, you have to sign an NDA. And then you need to navigate conflicts. So you'll remember my first slide of all my roles. So I'm a very conflicted guy. I try to avoid conflict, but unfortunately, I'm surrounded by conflict. So there's conflicts of interest and conflicts of commitment. I have to always disclose all of these roles that I have. People need to know that I'm a radiologist. My income is derived from reading scans. So and I'm a co-founder of this startup company, and I'm also an academic who's my academic career is based on developing these technologies. So that's a lot of conflict. I have to retain my academic integrity throughout this. Each of us does. Numerous people in our, everyone in our team has to retain their integrity and feel proud of what they're doing and not be doing anything on the sly or something. And we have an obligation to our partners and colleagues and our community as professionals to act with integrity and do the right thing. And I'm really proud of the way Medo does that. Once you start building a company, you develop some intellectual property, and you need to protect that. So actually, intellectual property, it's a bit broader than patents. So if we're building hardware, like the people who built this probe, this particular one, there's several manufacturers of hardware. If you're going to build a probe, then you make patents on it, because you need to make sure you can, not just let some other guys make a clone of it, and you can fight them. But software is a hard thing to patent. Software is basically an idea written down, right? This is an idea. And so it's a patent is at its core an idea, but it's like, how do you patent a process that can be done several slightly different ways and get to the same place? It's just hard to know. How can you patent a software process? We're working on different ways, and we have several quite key patents, and some companies move very aggressively to patent many, many things, and some companies do less of the patenting, preferring to spend their time actually building stuff rather than patenting it. So, and then where, too? Do you do this in Canada? Do you go to the US or the EU? Do you go to China? It's costly and time-consuming to do this. So the question is, how much of your limited startup resources do you put into actually protecting your IP versus developing your IP? And so when time and energy are precious, it's hard to know that balance. And so Medo has a strategy, and everybody needs to have that strategy if you're doing this. Now, in the medical AI field, you need to have regulatory approvals. It's very important that you're doing this to look at patients with that are either healthy or have some kind of disease or pathology. And whatever you do, like the Hippocratic Oath, first do no harm, right? So it's very important that a product needs to be approved from a regulatory point of view and allowed to practice so that it's not dangerous and can provide some benefit. So in Canada, our tool, the Medo tools, are a Class 2 medical device. It needs an investigational testing authorization, which just allows you to go and test a device on patients. You also need a medical device establishment license and the actual license for the device. And you need your FDA clearance and CE approval if you're working in the US or in Europe. And we've acquired a bunch of these over the last few years. And then you need a product. Now, this is where, our first one, of course, was built to be this beautiful, flexible tool for experts. There was so many bells and whistles. You could make 3D models and render them in different colors. It was the most beautiful thing ever. Then when we tried it out in clinics, we discovered that we need a product people actually want. And this one was too slow, too complex. The design was not centered on the users. It was centered on us who built it. So we had to start again, basically. We had to just go back from ground up and redesign a much simpler app. And we had to field test this lovable product. This is what it does. Here we're scanning a baby's hip. There are the pictures coming in. See that little progress bar? It's acquiring images that it thinks are good enough quality to analyze. And the sonographer is just holding the probe, is scanning the baby's hip, and then it waits for the diagnosis, and it says the hip is healthy in that case. So that's the AI working in real time, and that's what is needed in the clinic. We did not have that with version 1. So you also need marketing. Once we've got this thing, you have to set up connections with people all over the world if you're going to market worldwide. Need all these different connections. And so we have a set of beta testing and development sites that we've worked together with. And it's not advertising, right? This is like, trying to build a community that can work with this. And then you need a business plan. Now, we have the long-term vision of where we'd like to be, but just like when you're building a bridge, and here are some pictures of a bridge that was built in the Edmonton River Valley in the last couple years, that bridge has to stand up every minute that it's being built. So, you extend it a little bit, it has to keep standing. It can't just fall over halfway. So, in a company, cash flow has to be preserved. Bills have to be paid. Every month, everybody needs to get paid so that they can feed their families. And so you have to plan the cash flow and plan how you're going to proceed like that. And I'm terrible at that, but luckily Dordush is much better at that. Now there's another use case that we've developed. So beyond hip, we moved into many other things. Thyroid, Dinesh has been scanned with thyroid. The concept there is that thyroid nodules are difficult to evaluate to understand, are they benign or malignant? Is this cancer or not? And the AI can help us automatically detect whether it's benign or malignant, and then it can even just calculate automatically basically what size that is, and that's very useful. So this is a product or another application that's very useful in a radiology clinic environment, and this has been developed very tightly with MIC, my radiology partnership, and that we're excited about where that's going. I won't go into detail on this, but our plan is to recognize many other body parts. There are lots of other organs and clinical scenarios that we would like to use ultrasound for, and we envision building more and more of those. So as we kind of wrap it up, let's look at where we're at. We're looking at our path to real impact. What we actually did is we built a tool to analyze for hip dysplasia. And then we went to validate that the tool worked. We made it a nice paper. And then we went out to see if users existed that might want to have this thing. But that's kind of like a solution in search of a problem. And a lot of academic work is like that. What we should have done is start with the user and the need. Start with, this is what people need, and then build a tool to meet that need, and then validate that it works. But of course, hindsight is 20/20. We always, we could have done it better, but that's how we did it. So we have the vision right. I'm very proud of our vision. The path, we started backwards, but we turned around and pointed the right direction eventually. The team is exciting. We've got the right people. The product development is super inefficient, and I think it's always like that. I think it's hard to avoid an inefficient process. We've learned a lot, getting a lot better at it. And then upscaling, expanding, marketing, this is where we're at now, is trying to build further. So in conclusion, building a startup company from academia has a lot involved in it. It's, I think the reason that I'm in this, the reason I'm here doing this is to have a real impact, to really make the things that we've been thinking about academically actually happen. I want every baby to be screened for hip dysplasia. I want to be able to scan someone's heart or thyroid with an ultrasound in a clinic or just anywhere and get an answer as to whether there's pathology or not. Success in this needs this vision, it needs a team, it needs a product people actually want. There are users that want to use this thing. There's IP and regulatory approvals, have a good marketing and business plan, the financials are in place, and you really need a lot of humility and good fortune. And at the end of the day, it's for the people. And there are many people I'd like to thank here. Thank you very much. So we have time for some questions if anyone would like to ask. There's about 10 minutes left. Yeah.
Hi, good morning. Gonzalo Herrera, Corporate Relations with the University of Alberta. Congratulations. It's just been so inspiring to hear your journey. And you guys are achieving great things. And it's just great to see. And I can see how the energy flows when you guys talking. So congratulations for that. And I would like to ask you about your work-life balance. I love when you put on your I don't know if that exists. I don't know if that exists, but I love when you put on your slide that there's a non-union job. And so lately I've been talking a lot about with entrepreneurs about how there's that conception that if you're an entrepreneur, there's not a work-life balance ever. Can you tell me about that? Can you elaborate about how do you balance that, all the great things that you're doing or your talent with your family and fun and other things?
I think you're in the best place to respond to that. I'm not gonna get this, or no one gonna start a company ever again.
Well, it is a central challenge, in life everywhere to maintain some kind of balance with it. And I mean, as you can see, I have 3 children, and I have a full-time, more than full-time clinical and academic role. I think to maintain balance, you have to. There's a philosophy to it for yourself personally, right? It's just, I'm going to go for a run. I'm just going to go for a run. Like, that's it. It's going to happen. It's a top priority that I'm going to go do that and take a break. And when you're doing that, your head is, actually churning around thinking about how you're going to proceed. You actually, when you take a break, then you actually, or are doing something personal, or even, if I'm with my kids and I'm enjoying them, I'm not thinking about the work, I'm just not. I'm thinking about my little boys and taking a train. And, while I'm doing that quietly in the subconscious, my own neural network is processing, and I'm not even aware of it, and it's fine. And so, and then I'm, happy and contented and enjoying life and coming at things in a way that, the time that I do spend on something with Medo or something at the university is more productive. So I think there's a big difference between working harder and working smarter. And so that's a personal philosophy. But in terms of how you actually, there's so much work to be done, right, in a startup. How do you actually do it and retain some sanity and some balance? I guess you have to know how to delegate these things and give them, how to pick people on your team that can have certain roles that can, you can't do everything. You couldn't expect yourself to do everything. And you can have, your brother can do this, and your first employees can do this. And this is something I'm spending too much time on, so I need someone to help with that. And so, I don't know if that's a way that you think of it, Dornish.
That's a wonderful answer. Just one thing I wanted to add to is that I keep hearing the word work. I never saw what I do for Medo as work. Mm-hmm. When you have that much of passion and love, it doesn't come across as work. So you have to ask me about passion and something else balance, not work.
That's fair. Yeah.
Hey everyone, I really enjoyed your talk, so I appreciate that. So I'm in healthcare myself, and I wanted to ask, how are you navigating things with Alberta healthcare and the medical legal thing? Because I know that's the big hurdle when you have AI and things like that, because I can understand there's so much with Alberta Health, with the Netcare and all the things that come with that. So I just want to get your take on that.
You do know that this is a live talk, right?
Oh, I'm sorry. My apologies.
Well, that is a central challenge, and that's true. It's in Alberta. That's a challenge in Alberta, but that's a challenge everywhere. Any jurisdiction you have to work with. Like medicine is regulated from the government political objectives, from medical licensing and medical professional obligations. We just work with the people. Like, I have connections through my AHS work as a hospital radiologist. I have connections through the university. We just work with our network of connections and explain openly and transparently what we're doing, and try our best to move forward. I mean, we're just. I think it really comes from making relationships with people that understanding what they can help you with, and trying to convince people basically to share our vision. And if you can get people to agree with your vision, which I think explains itself, right? If you have that vision, then if you can get people to go along with that, people will go and help try and navigate these little speed bumps that keep coming up. Oh, here's one there. Yeah.
Two questions. Hi, Jeff Owen, Global Affairs Canada. One, it seems like it's contrary to your philosophy, but are there different regulations in the private healthcare side of things where you could introduce the tech in private clinics and gain acceptance there? And the second part of the question was, one of your challenges you identified was conflicts. Is that due to you guys challenging the status quo?
Those are two pretty big questions. Okay, so first, on the private side, so yeah, Canada officially only has a public healthcare system. We have it's publicly funded. There's really one payer, but there are actually lots of private providers. So, a family doctor is a private provider who bills the government, but they're their own business. So if you can convince a family doctor that they're going to be helped by having this Ultrasound AI tool, then they'll buy it. Right? Yeah, so actually, there's in that kind of a setting, that we can market just like that. So, the worst would be if it's monolithic and everyone is only a government employee. But physicians are not government employees. Physicians are, private contractors that send a bill to the government. So they can decide, well, it helps my practice to have this thing. So that's a key thing about our market. And then the other question about conflict. Can you say that again?
I was just asking if the conflict stemmed from your technology challenging the status quo.
I see, yes. So important question. So I'm a radiologist. Radiologists are medical imagers. Our professional job is to interpret medical images. If you're teaching a computer to interpret medical images automatically, obviously that's a bit threatening to radiologists. So, that's definitely like a transformation, making a healthcare system have more imaging in it, but being done by less experienced users. That's a pretty big deal. A lot of existing specialists feel threatened by that. A lot of people are threatened by that. But one way to look at it is if we're scanning everybody with ultrasound, then there are going to be, you could screen many people, but there will always be some that are more complicated that are going to need to go on to be assessed by an expert. And so actually the role of experts becomes more and more important in that setting. So
I think it's also about the way we look at the whole problem. Like when calculators and computers never got rid of accountants, it was actually a tool. Same goes for autopilot technologies. When it came, I heard that pilots felt exactly the same way that radiologists are feeling right now. But right now we sit on a plane, we don't even think about it. And it is being, a huge part of the task is being done by technology. And I feel it's the same thing. It's a tool that enables and supports clinicians. So it's also about the way we look at it.
The role, it's as I was saying at the session yesterday, is that the role of a physician is going to change the more AI we have. Just thinking broadly, the physician is going to be more and more the interpreter, the sort of the ambassador, teaching people about, teaching patients about what the AI does and the interface between people and AI. So there's a change. Physicians will have to adjust. Everybody has to.
And at the end of the day, the role of a physician is to take care of the patient care. The tool's going to change, and they have been changing throughout the history. But at the end of the day, it's about what is best for the patients. And the interesting part is that whenever I talk to clinicians, they immediately get it, because to them, it's all about patient care. So if it is better, then there is no question.
Startup environment like this. Thank you very much. What are some of the skills or experience and mindsets you'd want early employees to have in a startup environment similar to yours?
For me personally, whenever we were hiring, I was first of all focused on our mission, how much that person actually truly care about the mission, rest, and how much they're willing to learn and to adjust. And I think that also came from how much they actually truly care about that mission. Because if you truly care about something, you'll do anything and everything to get to that. And for me, whenever I was talking to someone, that was the first question I was trying to figure out. And obviously, they have to have some skills that is matching to the job position. But again, I will put passion for the mission above and beyond that, beyond the skill level. And I think it's really dependent on what kind of startup you talk about. We are a very mission-oriented kind of a startup. So I'm very specifically talking about Medo and startups that are mission-oriented. So it will be a very different story when it comes to different kind of startups.
I wanted to thank everyone for their questions, but that's all the time we have. I invite all of you to connect with the speakers on the app. But thank you for your time, and thank you, everyone, for the great questions.
Thanks very much, everyone.
Thank you so much. Thanks. Thank you.